In this video, we're going to make a pulse radar to detect enemies. This will be an object that we can place which sends out a pulse and detects any enemies or items it finds. Then in the end, we're going to convert it into a UI minimap. Let's begin! Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. So here's what we want to create. Over here you can see a bunch of enemies just roaming around, as well as some items scattered throughout the map. Now with a button I can hide the enemies. They are still alive and they are still moving, they are just hidden. With another button I can hide the items, and now I can hide the background. Now everything is invisible and it seems like we can only see a black screen. However, if I enable the radar pulse, and yep, there it is, there's our radar sending out pulses and locating objects and enemies it hits. With the collar we can identify that over here we have an item, and over here is an enemy moving around, as you can see by the location of the pings. So as the pulse reaches the end, it fades out and resets back into 0. I can press some keys in order to modify the range of my pulse, and there you go, now it is going much further. And with another key I can modify the speed. So there you go, just like that, pulsing out very quickly. So we're going to build our class in a nice way so we can easily modify these sorts of parameters. So over here we have our nice effect. Also in the end we're going to convert it into a nice UI element, just like some sort of minimap. So now I can move around with my player and I can look at the minimap, and if I hide the enemies and the items, there you go, I can still see them on my radar. So I can see there's an item in there, and I move and I capture the hidden item. So this could be used to detect cloaked enemies, or maybe a special minimap that showed the location of hidden items or Easter eggs. You can see this effect in action in one of my games, Survivor Squad Gauntlets. You can throw out a motion sensor which sends out pulses that locates enemies even when they're hidden. Since the game is heavily based on field of view, this effect works as an excellent mechanic. You can pick up the game included in the game bundle. Alright, so this is our goal, let's get to it. So here's our starting scene. Over here I have a bunch of enemies just roaming around, as well as some items. This is pretty much the same starting scene that I used for the radar effect video. Check the link in the description if you haven't seen it yet. In that video I cover a radar that sweeps through an area and locates items and enemies. Now in this one we're going to have an expanding circle instead. So here let's begin by making the visual. So a new game object, let's call this the radar pulse. Now inside let's add a 2D sprite. And over here in the project files I have this nice texture. There it is, you can see a circle with a fade on the inside. So this is our pulse sprite. And essentially what we're going to do is increase the scale of this game object over time. Okay, so this is our setup. Now let's make the script to control it. Over here let's make a new script, call it the radar pulse. And let's drag it onto our game object, like that. Okay. Now in here let's first grab our pulse transform. Okay, here we have it. Now let's also define a private float for the current range, and also another float for the range max. So on awake, let's set the range max at, let's say, 300, and then we make our update, and on update we increase the range by a certain range speed multiplied by delta time. And then if the range goes past the maximum, then we reset the range back to 0. And after all this, we apply the range to the pulse transform. Alright, just like that. So we should be able to see our pulse constantly increasing, reaches the maximum and resets. Okay, let's see. And there it is, and increasing and reaches the maximum, and it goes back to 0. So there you go, now we have our pulse constantly going up. Okay, great. Now let's see how we can actually locate our objects. So for that, in here we're going to use the physics2D, use the circle cast function. By now you're probably already familiar with how a raycast works. It sends out a ray in a direction, so it has an origin and a direction. In here it's similar, except we use a circle area rather than just a ray. So we do our circle raycast, which requires an origin. The origin will be our transform position. Then we require a radius, which will be our range. And then we need a direction in case we wanted to move the circle, but in this case we just want to test it exactly where it is, and we're simply going to increase the range. So in here, let's simply pass vector 2, 0. Okay, so we do our circle cast, which returns a raycast hit 2D. And now in here we can test for the collider. So if the collider is not null, then we hit something. So in here, just for testing, let's spawn a simple pop-up. So in here, I'm using the text pop-up function from the utilities. As always, you can grab the utilities for free from unticodemonkey.com. So this will spawn a pop-up. Let's spawn a pop-up saying ping, and let's put it on the position that it hit. So let's use the raycast hit and use the point. Okay. So just like that, we should be able to see a pop-up whenever it collides with some object. Let's see. Okay, here it is, and as you can see, the pop-ups are going out. However, you can see an issue, which is they are weirdly positioned. The reason is because we are setting the range on the vector2 local scale, so that applies the range on all sides. But then on the circle cast, we are using a size which is only a radius, so it's only on one side. So in here, instead of using our full range, for our circle cast, we want the range divided by 2f. Since essentially the range that we have in here is multiplied by 2, since our pulse circle will expand from both sides. So let's see. And yep, there it is, just like that. You can already see the pings are correctly located. So as the pulse expands, there you go, once it hits something, it triggers a nice pop-up. Okay, great. Now you can already see some issues. For example, you can see the issue with multiple pings for the same object. So essentially, as it expands, every single frame we're doing a raycast, so the same object will be hit multiple times over the same frame. So let's fix this by making sure that we only ping once per each object. So in order to do that, in here all we need to do is keep track of what objects we already hit, so we know which ones we can ignore. So up here, let's make a list. You can make a list of collider 2D. We initialize our list in here. And in here, okay, we hit something, but before we spawn the pop-up, we're only going to do that if the list does not contain this collider. Recast it to the collider. So we only run this code if it does not contain that collider. So if it doesn't, then we add it and we do our pop-up. Okay, there it is, just like that. This should be working. Let's test. Okay, there it is, increasing, and yep, fire the ping there, and a ping in there, and a ping in there. Okay, great. However, now it goes up, it resets, and now you can see an issue. We pinged certain objects, and we no longer ping those exact same objects the second time that the pulse goes out. The reason is because we are adding colliders to the list, so we need to make sure that we clear the list when we also reset the range. So over here, extremely simple, when we reset our range, let's also go into the list and call it clear. Okay, let's see. Okay, here we are, an increase, and yep, there you go, ping that one and that one. Now let's reset and try again, and ping that one again a second time. All right, so our pings are correctly resetting between pulses. Okay, great. Now the other issue that you can see is that we're not really pinging all the objects. Only some of them are actually being hit. This is due to the way that we're doing our circle cast. It stops as soon as it finds just one colliding object. So if multiple objects are inside the range, only one of them will be hit. The solution is very simple. In here, instead of using our circle cast, we can use the circle cast all. This, instead of returning just a single raycast hit, it returns an array of raycast hits. So this returns an array, and then all we need to do, let's do a simple for each and use the exact same name. And now in here, all the code is exactly the same. So here we get an array of all the collisions that occur inside this circle. And then here we cycle through them and spawn the same ping. All right, let's see. Okay, here we are, an increase, and ping that one, and that one, and that one, down, 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 and finally that one. And now it resets, and there you go, it's pinging all of them once again. All right, great. So we have our pulse correctly hitting every single item and enemy, and it goes up to the end and resets, and everything works exactly as intended. Okay, great. So with the logic working, now let's replace these debug pings with something more appropriate. Now over here in the project files, I have this nice prefab. It's essentially just a ping sprite and then contains a simple radar ping script. Here it is, the script. As you can see, it's pretty simple, very small. In here we just have a reference to our sprite render, and then we have some code over here running on every update. We're essentially lowering the alpha based on a certain disappear timer, and when it reaches 0, we destroy this game object. Then here we can set the starting caller and we can set the disappear timer. So just a very simple script in order to make sure that the alpha for the ping goes down and then destroys itself. So now we can go into our radar pulse script, and in here let's add a serialized field for our prefab. Okay, we have our field, and let's set it in the editor. There's our field, and just drag the prefab, okay. And now let's go down here. Here we are spawning our testing pings, and now instead of doing this, let's simply instantiate our prefab. We instantiate it on the raycasthit2d.point. Alright, so just like that, we should be able to see the pings instantiated instead of our pop-up. And there it is, and yep, there you go. As soon as it goes up, when it locates something, it spawns our ping. Alright, awesome. So now that we have this, let's set the ping caller based on what type of item we hit. So one ping caller for the items and one for the enemies. So for that, let's use the script. So this returns a transform for the radar ping transform. Then we can use the radar ping transform to get the component of type radar ping. So here we have our script, and now it's in here that we can call setCaller. So now in here, let's identify which one is an item and which one is an enemy. In here you can see on the hierarchy of the items and enemies. Here they are. The enemies are using this script, the character waypoints handler, and then the items in here are using the item handler. So we can use these scripts to identify what we are hitting. So in here, before we set the caller, let's go into our raycasthit2d. And we go into the collider game object. We get the component of type item handler. So if this is not null, then we have hit an item. And if it hits the character waypoints handler, then we hit an enemy. So now in here, for the enemy, let's set the color to a new color. Let's put red 1, green, and blue. Okay, so full red. And now for the item, let's put it on full blue. Okay, this should be working. Let's test. And here we are. And yep, there you go. The pings are correctly being instantiated, spawning in the correct position and using a nice color. So the enemies are pinging red and the items in blue. All right, awesome. Now let's just see how we can play around with the other function on the radar ping. So in here, the set disappear timer. So if we set it to the range max divided by the range speed, essentially we're making sure that the radar ping will only live for as long as until the range resets and reaches the same size. So here it is. There you see that ping happen. Now it vanished. Now it spawned again, vanished, and spawned again. Okay. So since we made this based on the range speed, over here we can increase it. And there it is. Now the pulse is going on much faster, but as you can see, they still ping exactly the same. So we only have one ping alive per each pulse. If we wanted, we could also multiply this by a certain value to keep it alive for longer. And there's the effect, and now you can see that each ping survives for about 3 pulses. So with this, we can actually see where the enemies go. So that one is stopped, now it moves, there was a ping there, ping there, ping there. So if we hide everything, we can see, look, there, enemy is in there, now he's moving down there, and down there, and down there. All right. So you can easily play around with these values to figure out what values best suit your game. So with this, the effect is almost done. Let's just add a couple more things. Let's first add a fade at the end of the range so it doesn't look so jarring, reaching the end and immediately resetting. So here on our update, let's start fading after a certain amount. So up here we define a float for the fade range. In here, let's put it the last 10%. So let's put the fade range at 30. And then down here, well, inside our update, let's test if the range is past the range max minus our fade. Then we want to start the fade. So we also need the color. Okay, so we have the color and the sprite render. So here we have our code. We're simply setting the alpha we're doing a lerp between 0 and 1, and the way we are calculating the t in here, this value will start off at 1 and approach 0 as the range increases to reach the range max. So we start off at 1 and then at 0. Then in the end, we simply set the sprite render to this color. Okay, so let's see. Okay, here we are, and yep, there you go. You can see a very nice fade at the end, so the effect no longer looks quite as abrupt. So it goes, once it reaches the end, the alpha starts to fade until it completely vanishes. And again, we're doing all of this based on fields. So in here, let's say the fade range is a bit longer, so let's say 100. And just like that, yep, there it is. We have a much softer, much longer fade. So you can see how you can play around with all of these values in order to figure out what best suits your game. Okay, so in here I have added some simple keyboard controls. Again, all our code works with some nice simple variables, so we can simply increase or decrease them. Let's see. Okay, here we are. Now I can press this button and increase the range, and there you go. Now the range is much further. And now I can press this button in order to increase the speed, and there you go. Now I can decrease the range, and let's make it, yep, just like that, very small, and make it bigger, and make it slower and faster. So as you can see, this effect is very easily adaptable. And again, hide all of the underlying objects. So there you go, no background, no items, no enemies. And as you can see, everything exactly working as intended. Alright, so just like this, we have our nice radar pulse effect. And now finally, just for fun, let's take this effect and apply it into a minimap. So I'm going to do pretty much the same thing that I did when I made the minimap video. So check the link in the description and go watch that video to see a step-by-step on how to create the minimap and render your scene onto it. Okay, so here I am with my player character that I can move around. And over here in the UI, you can see the radar effect working. And you can see by the pings that there's an item above me. So let's enable the visual. Yep, there you go. There's an item in there and it's being identified on the pulse. And I move and I capture it and there you go. I picked up the item. There are two more in there and there you go. Yep, there they are right next to me and I picked them up. And just like that, picked them up and they are no longer in there. So I can now hide the enemies as if they had some sort of cloaking technology. And there you go, I cannot see them on the map, but they still exist and I can see them on the radar. So there's one right there. So what I did was, first of all, make this UI element. Over here inside my canvas, I just have this game object. Inside, I just have this raw image. The reason why it's a raw image is so that I can add a render texture onto it. And this radar texture is actually what is displaying what that camera sees. So the camera that is printing onto this render texture is a secondary camera in here. So this camera is only rendering things on the radar layer, so over here only on the radar, and the main camera is not rendering anything on the radar. So all of the radar objects, like the ping and the radar pulse, as you can see, they are on the radar layer. So that way they are visible on the radar camera, but not on the main camera. And the radar pulse is simply a child of the player, so it follows along with him. So again, here it is, the full effect, and there you go, I can hide everything, and using the radar I can still look that there's an enemy right here. So just like this, we have our entire very nice effect. As you can see, this is a great effect if you have some sort of cloaked enemies in your game, or just some hidden Easter egg items. As always, you can download the project files and utilities from unitycodemonkey.com. If you liked the video, subscribe to the channel for more Unity tutorials. Post any questions you have in the comments, and I'll see you next time.